Welcome to the Computer Network series. Before we begin, let me ask you a simple question. Have you ever wondered how data travels from your laptop to your Wi-Fi router? When you send a WhatsApp message or watch YouTube videos, the data has to travel through some path, and that path is called the transmission medium. So today's class we'll be discussing about one important category of transmission medium called the guided or the wired transmission medium. So what is this transmission medium? The transmission media is a physical path or the communication channel through which your data travels from the sender to the receiver. Think of it like a road. If a car wants to travel from one city to another, maybe it needs a road. Similarly, if data wants to travel from one device to another, it needs a communication path, and this communication path is called the transmission medium. The transmission media is classified into two. One is guided or the wired media, where signals travel through a physical path, physical cable. The second is unguided media, where signals travel through air or space using electromagnetic waves. Today's topic is about guided media. We'll focus only on wired communication. The signals are securely guided along a very strong physical medium from the sender to the receiver, and this media offers a high reliability, and this forms the vital backbone connecting numerous computers to local switches, Wi-Fi routers, and the ISPs. There are three types of guided media. The first is twisted pair cables, the second is a coax or the coaxial cable, and the third is the optical fiber cable. We'll study each one in detail, understand how they work, where they are used, and finally compare all these. Let's start with the most commonly used cable, that is the twisted pair cable. It consists of two insulated copper wires twisted around each other. You can see it in the picture. Now you might wonder why the wires are twisted. The answer is going to be very simple. When electrical signals travel, nearby electrical devices can create unwanted signals called noise or electromagnetic interferences. If the wires are straight, this interference directly affects the signal quality. But when the wires are twisted, the noise introduced in one twist is almost cancelled in the next twist. So as a result, communication becomes much more reliable. So this simple twisting technique greatly improves your signal quality. There are two types of twisted pair cables. Number one is the unshielded twisted pair. It has no metallic shielding. Because of this, it is cheaper, lightweight, and very easy to install. UTP is commonly used in Ethernet LANs and telephone lines. Popular examples include Category 5E, Cat6, and Cat6A cables. On the second, it is STP, which stands for Shielded Twisted Pair. Here, an extra metallic shield protects the cable from interference. So this makes it suitable for factories, industries, and places where heavy electrical equipments are there. However, this STP is quite more expensive when compared to the unshielded twisted pair. Let's summarize. The advantage of twisted pair include low cost, high reliability, easy installation, and wide availability. On the other hand, the drawbacks include the limited bandwidth, shorter transmission distance, usually around only 100 meters for Ethernet, and higher susceptibility to interference, especially in the case of unshielded twisted pairs. Fine. Moving on, it is the coax or the coaxial cable. So a coaxial cable has four layers, as you can see in the picture, the right. At the center, we have the copper conductor that carries the electrical signals. Around it is the dielectric insulator, which separates the conductor from the shield. Then comes a metallic shield which blocks the external interferences. Finally, the outer plastic jacket which protects the cable physically. So because of this layered construction, coaxial cables offer better protection against noise when compared to twisted pair cables. So why do we use coax? They provide higher bandwidth than twisted pair. They have better immunity against noise also. They can transmit signals over long distances, very important. However, these also has certain limitations, the disadvantages. They are more expensive, They are thicker and less flexible, but installation is also slightly more difficult. So where are these coaxial cables used? They are commonly found in cable TV television systems, CCTV cameras, broadband internet connections, and cable modems. Moving on is the fastest transmission medium, the optical fiber. Unlike the previous cables, optical fiber does not carry electrical signals. Instead, it carries data using light. An optical fiber consists of three parts. Number one is a core through which the light travels. Number two is the cladding, which reflects light back into the core. And the third is the protective jacket, which protects the fiber from physical damage. So the working principle of this optical fiber is the total internal reflection. This means light entering the core continuously reflects from the cladding and it reaches a destination with a very little minimal loss. So this is the reason why fiber optics are extremely used in high-speed communications. Again, it is divided into two types. The first one is single mode fiber. This is a very small core. So the structure of this single mode fiber itself is the core is very small in diameter. Only one light beam travels through it. So this minimizes signal distortions and it is quite very ideal for long distance communications and offers very high bandwidth. On the other hand, the second is the multimode fiber. This core is quite larger and multiple light beams travel simultaneously in a multimode fiber. So it's mainly used for shorter distances compared to a single mode fiber. Primary applications include office networks, campus networks, and data centers. So summarizing optical fiber, its advantages are extremely high bandwidth, very low signal loss, immunity to electromagnetic interferences, excellent long distance communications, and high security because tapping optical fiber is very difficult. However, there are some disadvantages. Installation cost is quite high. The cable is fragile. Repairing or splicing these fibers requires very skilled technicians. Optical fiber is widely used in the internet backbone, as you know, 4G, 5G, hospital banking systems, even undersea communication cables connecting different countries. So look at the comparison of the guided media. Twisted pair and coax both use electrical signals, whereas optical fibers use light. Bandwidth is the lowest in twisted pair, moderate in coax, whereas highest in optical fiber. Noise immunity is poor in twisted pair, better in coax, and excellent in optical fiber. Transmission distance is short for twisted pair, medium for coax, and very long for optical fiber. Cost increases in the same order. Twisted pair is the cheapest, coaxial is moderate, and optical fiber is quite expensive. In terms of applications, twisted pair is mainly used in LANs and telephone networks. Coax is used in cable TV, CCTV, and broadband internet. Optical fiber forms the backbone of the internet and modern telecommunication systems. So whenever you are asked to choose the transmission medium, remember this simple rule: twisted pair for low cost networking, coax for better protection and medium distances, and optical fiber for high speed long distance communication. If you found this video useful, don't forget to like, share, and subscribe to the channel. Thank you. Happy learning.